Okay, so you should have your foldable out. Alright, the next set of instructions for the foldable. Alright, on the very back page of the foldable, okay, you should be on page 8, okay, on the very back page, you are going to copy this format, okay, the title should be Earth's History, just like this, okay, Earth's History, just like this, okay, and then you're going to write, okay, write a line, years ago, and then write facts underneath it, okay, should be set up just like this. I'll come around and show you guys if you can't see it, alright. That should be on the back of page 8. You're going to copy that format. Once you are done copying that format, then you're going to flip to page 3 and 5. You need to grab a pair of scissors in the back. Okay? You need to cut page 3 and 5 like this. There's dotted lines. Right? Should be cut just like this into flaps. Okay? Follow the dotted line. Do not cut. Okay? Do not cut the title. And if you haven't stapled yours yet, do not cut all the way through the paper. You need to stop at the title. Okay, so when you have it all together, it should look like this with your flaps. Alright, and then you should have this format on the back of page 8. Does everybody understand or have any questions? Okay. So go ahead and take a few minutes, copy this down. I will show you guys what it looks like so you can see an example. No, you have 6 to do. My example just only has 3. You need to write all 6 of them. Okay, so just like this, alright, just like it is up on the board. Okay, just like it is up on the board, okay, you do 6. Alright, so just like this, just like as it is up on the board, you do 6. Okay, just like this up on the board, you need 6 of them. Okay, so it's on the back, yep, just like this, just like it is up there. That was my door battery, so you should be on the back of this one. Should be on the back of the map, guys, back of the map. Okay, just like this, on the back of the map. Don't worry about doing the rest of it right now, just worry about this one. Okay, so it should be just like this, okay, on the back of the map, on the very back page. Okay, should be just like this, right on the back of the map. Okay, maybe it should be just like this, okay, on the back of the map. You should have 6. Okay. You need 6 of them, guys. Make sure you leave a little bit of space in between each one so you can write down the facts. Gentlemen, okay? But you should be cutting. All the staplers should be over there. Oh, I need staples. Okay.
Do you have a staple thingy that pulls it out?
It's over there on the table as well. Okay, can you hand me that stapler so I can get new staples?
Well, I have a funny story about that.
Don't worry about coloring it, okay?
You don't want it?
No, don't worry about it, yeah.
Oh, okay.
Yeah, we can finish coloring it another day, okay? Yeah.
I was just
Yeah, no, it's okay. Just make sure make sure you get this page done, okay? And then you cut the 2 pages. Okay. Okay, so once you're done writing on the back, you should have your pages cut. Did you cut your pages? Guys, you should have your pages cut. The next direction was to cut your pages. No, guys, I didn't say anything about searching anything up. I just said I gave you instructions to copy down page 8, which is on here, up on the format up here. Okay, and then you were to cut pages 3 and 5. You don't need to look up anything.
We have to do all 6 of the
Yes, you need to do all 6. I just didn't finish writing them all.
all 6.
Thank you, sir.
If anybody needs to see my example, I have my example up here.
Ow.
Okay, so make sure you're cutting the pages on the dotted line. Do not cut through the titles. Stop once you get to the titles. It looks like this.
Is anybody not here today? Anybody seen it? Somebody not here today?
not here. He's in New York.
Anthony's not here?
Yeah.
Yeah, he's not. We left him right at like.
Is Nicola here? Yes, she's here.
Can I have something?
Then we can color the rest.
No, guys, you don't need to color today. We're not coloring today. No coloring today. Don't worry about it. We'll finish it later.
We don't cover it. We're just gonna be doing our package. Did you say bed sheet? Oh, I thought you said bed sheet. I was like, okay. I get it, you're tired. Well, hey, and then I gotta use this scarf as a blanket.
Why don't you call it all of it?
Oh, shit. Early? I've been trying to go to bed. I'm trying to go to bed at 6.
Miss, make sure you cut pages 3 and 5. Anybody still need the format up here up on the board? Anybody? Anybody still need the format up here up on the board? Everybody good? Alright, once you guys are done, you guys need to get logged into GimKit. Okay, once you guys are done, keep your foldables on your desk, please, and get logged into GimKit. Keep your foldables on your desk, get logged in.
Yeah, dude, just ask her.
You look these upside down.
No way.
Years ago, right?
Those are yours? Those are yours?
kind of
Those
no.
are there.
Okay, so get logged into GimKit.
Put it towards the side, like level this.
Once you're done cutting, okay, get logged into GimKit. Cut, yeah?
Pretty cool. You logged into GimKit, guys?
We stopped abruptly after that. Yeah. It's like, okay.
Here's some scissors. Done.
I like the way you stapled this. It really makes me have to put like the damn scissors just so I can cut it.
Keep your foldables on your desk.
Because this one right here.
Foldables on your desk. You need to get logged into GimKit. Gentlemen, you guys getting logged in? Gentlemen, let's go.
The next assignment came the paper and just stapled the thing around.
That's 2 bars in the whole.
Code is 19983. 19983.
It's annoying though, because I don't have enough time to pull pro.
Are you guys working together?
Yeah.
Get logged in again, Kit. Cut? Cut the pages. Just like this. You cut like this. Don't worry about that right now. We'll cut it in a second. Worry about getting logged in again.
Just like, you know.
Who still needs another moment to get logged in? Anybody? Anybody need an iPad? I have one more. Anybody need an iPad? I have one more.
Hey, Nada.
I'm trying to see a white. There's just little tiny little rectangles.
Alright, anybody still need a second to get logged in? Is everybody good?
No.
All of a sudden. Alright, here we go. I'll put the code up on the board if you get booted out. Class speed is period 2. They got $12,000 today. Don't forget to use your power-ups, your upgrades. Dalton's in the lead. Use your power-ups and upgrades. Logan's in the lead. need to go away, headphones need to be out and gone, please. Phones away, headphones out and gone. Your foldables should be out on your desk. Nice job, Logan, Jackie, Dalton.
I always feel like the house is on my second. It's really nice.
Guys, don't forget to use your extra credit before the quarter ends. It resets for quarter 3. Okay, so if you have any extra credit points, make sure you guys use them before the midterm. Okay, so make sure you guys use them. Alright, make sure your phones are away. Headphones should be out and gone.
Wait, when's that next test?
What'd you say?
When's that next test?
What next test?
Oh, we have a test.
Well, we have a quiz next week, and then we will have our midterm the day of the midterm. 11,168. But I have to do the numbers.
Wow. I honestly don't like that we lost like 2.
Alright, guys, make sure your phones are away. Foldables should be out on your desk.
Show me.
Question breakdown. Guys, what's the mantle?
I just got direct deposit today, so maybe.
Sit down. Okay, remember, guys, the mantle, we didn't do so hot on this question. Look. Okay? Mantle, right? What's the outermost layer of the earth? The crust. Then it goes what? And then what? Outer core, and then the very most inner part? Inner core. Okay? So mantle is the middle part of the earth. A few of us made a mistake on coloring our foldables the other day, okay? Remember, it goes crust, then mantle, then outer core, then inner core, okay? Another question, evidence of the continental drift theory. All right, remember, okay, looking at this one, and the answer here, remember, when we talk about, you need to get a desk, please. Okay. When we talk about proving the continental drift theory, remember, they found fossils of both plants and animals that were identical to each other, that were on 2 different continents in the world that we live in today, right? So we found fossils that are identical in South America to those animals that are in Africa, right? Because those two continents used to be fused together. Okay, so that is some evidence as to why the continental drift theory is around today. Earth is approximately what? What is it? Yeah, there you go. Okay, so Earth is approximately 4.5 to 4.6 billion years old. Okay. Alright, so what you guys are going to do now, alright, so what you guys are going to do now, okay, you guys should have cut your pages, okay, we should be on page 5 today, we're starting on page 5 today, so you should have it cut into your 3 sections, your divergent boundary, your convergent boundary, and your transform boundary. What you're going to be doing, okay, is on the back of each one of them, okay, so you should be on, okay, the back of page 5 or page 6, okay, so the back of page 5, you guys are going to be taking notes on each one, right? I've highlighted the key things that you need to write down in yellow, so anything you see in yellow that corresponds with that type of boundary, you need to write down on the back, so it'll be like a flippable thing, okay, so you can see the picture, flip it, and read the facts. Does everybody understand that? Okay? Alright, so your 3 types of boundaries you have, alright? Divergent boundaries, what are those?
Move apart.
Right, they move apart, okay? So you have 2 parts of you have 2 plates that move apart from each other. Now what's going to come up between those 2 plates?
Magma.
Magma, good. Okay, so magma, right, and then what is that the process of? What's the process called? Good, seafloor spreading, right? So you have seafloor spreading, right? So you have magma that comes up through a divergent boundary, and then you have the formation of new what? Crust, good. Or seafloor, yes. Okay, so you have divergent boundaries where you have seafloor spreading, you have magma coming up through. You have convergent boundaries, what are those?
So, together?
Close, right, they come together, okay? They're converging, right? They're meeting together. Okay, so you have 2 plates meeting together. Now there's 3 different types of them, okay? So your convergent boundary, you'll need to leave a little bit of space to write some different facts. Then transform, what are your transform boundaries? Like right here. Yep, they slip past each other. Exactly. Okay, so your transform boundaries is when they move past each other. Now, what can be generated when 2 things rub each other? Friction. Good. Okay. So this is a lot of times where you're gonna find what's gonna happen here. Earthquakes. Good, because you're gonna have those faults, right? Those cracks in the earth from them rubbing together. Good. And then earthquakes can be generated. All right. So the first one we're going to start with. Well, we're gonna talk about tectonic plates really quick. Okay, so remember, tectonic plates, you don't need to write this anywhere. We're not writing specifically to any boundary yet. Tectonic plates are composed of lithosphere. What's lithosphere? Crust, good. Okay, so our lithosphere is our crust. It's the very outermost part of our Earth. Okay, moves as a coherent mass, which basically means, right, one whole plate moves all together with itself. So the North American plate is moving, okay, all as one huge unit. It doesn't, one part of it's not moving one way and the other moving the other way. No. Okay, they all move as one huge mass together. They may contain oceanic and continental crust. Remember, your oceanic crust is underneath your oceans, and your continental crust is underneath your land masses. All right, so those are your 2 types of tectonic plates. And then you have your 3 different types of boundaries. You have your divergent, convergent, and your transform. Okay, so this is what each one of them looks like. Divergent with them moving away, convergent with them moving together, and then you have transform where they're sliding past each other. Alright, so the first one, divergent. So this should be on the back side of divergent on your foldable. Okay, so on the back of page 5, make sure you're writing under divergent boundary. Make sure you're writing on the back side of divergent, okay? Don't write under convergent, don't write under transform. Okay, we're writing everything for divergent. Okay, so make sure you're on the back side of divergent here. And plates move away from each other. Okay, so again, you have 2 plates that are moving away. Magma is coming up through the crust, creating seafloor spreading. What happens to that magma when it meets that cold ocean water? Hardens. Good. It cools down and it hardens. Right? And then that hardened magma settles. Right? And then you have magma that's continuously being pushed up through, pushing that cold, hardened magma away and creating new crust. All right, so that's a continuous process that's happening all the time. So new crust is being formed here. So what's the age of the crust here right at seafloor spreading? New. It's brand new. Okay? What is it maybe way out here? Old. Okay? So the further you get away from the ridge, the older the crust gets. Right? The closer you get to the ridge, right, the younger it is. Okay, so make sure you have those 2 bullet points written down on the back of your divergent boundary. So you have 2 plates that move apart. They run through ocean basins. You're going to find your divergent boundaries under oceans. Now there's maybe a couple exceptions, such as here in Africa where it runs through the landmass in Africa. But most of these divergent boundaries where you see sea floor spreading, and the reason why it's called sea floor spreading is because it's under the ocean, right? It's found in these ocean basins, right? Found way out here in the middle of oceans. Look where these arrows are pointing, right? These are moving away from each other. What's this big green line here? Mid-ocean ridge, good. Okay, so the Mid-Atlantic Ocean Ridge, right? Okay, so this is why the United States is moving further away from Africa, and Africa is moving further away from us. Our 2 plates are diverging away from each other. So there's seafloor spreading in between the 2 of us, so it's pushing our crust further and further away from each other. Okay, so divergent boundaries you should have run through ocean basins on the back of your foldable. Anybody have any questions so far? Good. Most of this should be a review for you guys if you took this last year. Okay, so at divergent boundaries, there's some characteristics of the seafloor that you'll find. You'll find mid-oceanic ridges. What are those? What are mid-oceanic ridges? Good, underwater mountain ranges. Okay, so those are underwater mountain ranges, right, where you have magma coming up through, new crust being formed, old crust being pushed further away. You'll also find transformed faults. Remember, faults are cracks in the crust of the earth okay, that can cause earthquakes sometimes. And then you also have what are called rift valleys. And so these are formations of the ocean floor that are characteristics associated with the divergent boundaries. So you can see here in this graphic, and you can see the magma coming up, pushing up, okay, it hardens and it pushes the old crust further away. It's a continuous process that's happening all the time. Some areas faster than others, some areas slower than others. It just depends. But you have magma being pushed up through, okay, and old crust being pushed further away. Anybody have any questions? So you should have these 3 examples written down on the back of divergent boundaries. Good. And so here's just some examples, right? Like I said, most of these are found in ocean basins. Some of them are not. This one here in Africa specifically is found on the continental landmass. Right? So you have 2 parts of Africa basically spreading apart from each other. This is where you're going to find a rift valley where there's literally, because 2 plates are being pulled apart from each other, there's a valley that's being created between the 2 of them. There's no magma coming through or no magma coming up, but it's just 2 pieces of land being pulled apart. So the Red Sea is every day is getting larger, okay, in width. You also have the Mid-Atlantic Ridge. Look how large it is. Here's Florida, right? Look how tiny we look in comparison to it. Runs all the way down from almost the Antarctic Ocean, okay, all the way up to here up by Greenland and Iceland. So extremely large, but again, hey, that's your underwater mountain chain with a lot of seafloor spreading that's going on there, and those two plates are being pushed further apart from each other. Next, convergent boundaries. Okay, now you have 3 types. Okay, so you might want to structure it so you can have room to write information for all 3. There are 3 types. First one, ocean to continental. So you have oceanic crust meeting continental crust. What does the oceanic crust always do? Goes under. Good. Oceanic crust always goes under. Okay. You have ocean to ocean. So you have oceanic crust meeting oceanic crust, and then you have continental to continental. Those are your 3 types. Plates are moving towards each other in convergence, so which means that they are literally running into each other. Okay? Guys, put your heads up. Heads up. Okay, crust is being destroyed here. Right? So this is not where seafloor spreading is happening. Magma is not coming through here. Right? You have crust being destroyed in this process. Melted down, destroyed, recycled. So these are your 3 types. In the next couple slides, you'll find the information for each one of these. Okay. Anybody need a minute to write? Okay, so make sure you have a little bit of space for each one of those so you can write information according to each one. The first one you have is oceanic to continental. Now remember, you just need to write the stuff in the yellow. You're welcome to write more information if you like to, but it's not required. Right? So you can just write the stuff in yellow, or if you'd like to add to it. Oceanic to continental, that is when an oceanic plate meets a continental plate. Why does the oceanic go down below the continental? Think about it. Why does the oceanic go down below the continental?
Heavier.
Heavier, good. Right? Because things that are more what? Sink. Dense. Right? So things that are more dense are going to sink. So the oceanic crust is made out of heavier materials, and the continental crusts are made out of lighter materials. So that's the reason why oceanic is always going to go underneath the continental. Now, what's this process called? When it goes underneath. What's the process called when the oceanic goes underneath the continental? Subduction. Good. Okay, so subduction, right? That's the process of an oceanic plate going underneath a continental plate. What happens to that plate?
It's melted.
Melted, right? It gets melted. It gets superheated by the mantle, and it gets recycled all over again. Okay, but the key thing here to remember is as soon as this starts to dip down below and get heated up and melted, right, some of that magma is going to push up right away. So we have the formation of what? Volcanoes. Maybe some mountains, might depend. But we're usually going to have either trenches formed here or volcanoes formed here. Because that magma is going to be pushed right up through. Not a lot of it, but some of it will be pushed up through here. The rest of the crust will go down, melt, and restart that process of seafloor spreading at a divergent boundary. Okay, so the biggest thing to understand here is oceanic crust always, okay, subducts underneath the continental crust. Anybody have questions? Good? And so here's just an example. You don't need to write any of these. These are just, I mean, you're welcome to write some if you want, but so oceanic and continental crust, you have the Cascades ranges, the Andes, you have in Alaska as well, huge volcanic range. So some characteristics, right, of these oceanic and continentals meeting are large volcanoes. You have subduction zones where the plate is actually going underneath. You also have trenches. Okay, so what can happen is when one goes underneath the other one, it can kind of tend to pull the other one down a little bit, causing a trench, okay? It's not going to make the other one go down and get reheated and melted down, but it just causes it to be pulled down just a little bit. And then oceanic crust obviously subducts underneath. So this is just a picture just showing you some of the volcanoes that are formed around our world from oceanic crust meeting our continental crust. So the next one, right, we have oceanic to oceanic. Right, so this should be still on the back side. And on the back side of page 5. But you guys should be writing again, remember, so you should be on convergent boundaries, on the back side of convergent boundaries. Okay. So you have oceanic crust and oceanic crust meeting. Okay. Well, now what happens when two dense things meet each other? What's going to happen? Well, one's going to be a little more dense than the other one. Okay. So the oldest oceanic crust is going to subduct underneath the other one. The one that is slightly younger is going to be a little less dense than the older one. The older oceanic crust is going to subduct underneath. Okay? And then remember, when we talk about subduction, what gets pushed up in subduction? What gets pushed up? Magma. Good. Okay, so magma gets pushed up, and then we have the formation of what out in the middle of the ocean? Volcanoes. What do we also call those? Islands, also called what? Yep, say it. Hotspots, good. Okay. So you have what's called hotspots. Hotspots are islands or volcanoes that pop up in the middle of the ocean. That is due to two oceanic crusts meeting each other, one subducting the other one, pushing the magma up. Okay. What United States state? Good. Hawaii. Hawaii is all hotspots. Hawaii is all made from two oceanic crusts meeting, okay, pushing magma up, and that's how all of our islands are created out there. They're all hotspots. Anybody have questions about that? Good. Okay, some examples of the islands you have are, you have the Japan. Japan is one. Indonesia, the Philippines, the Caribbean islands, Altuan Islands. All of these are examples of hotspots where two oceanic crusts meet, and you have magma coming up through, creating basically new land masses. Okay, volcanoes. Yeah.
This is the Mariana Trench one.
It's a converging. It's a trench forming one. Mm-hmm. Yep. And so that's not considered an island though, or it doesn't. It's not with this process specifically. But okay, so Japan, Indonesia, the Philippines, all of those are hotspots. They were all formed by two oceanic crusts coming together, pushing magma up through, and creating new land masses, or hotspots, volcanic spots out in the ocean. Next one you have is continental to continental. Continental to continental. Here you have two continental crusts coming together. Alright, now you have something that, two crusts that are coming together that are not that dense. Alright? Usually our lithosphere isn't that dense. Right? Our oceanic crust is usually denser, but you're talking about two continental crusts, which usually aren't that dense. So what happens is when they meet together, they push each other with opposing forces. Okay, right? Did you get this stuff on? Okay, they come with opposing forces, right? And then what they do is they push upwards on each other, creating what? Mountain ranges. Good. This is how Mount Everest is formed. The Andes are formed. Part of the Andes, I should say, not all of them. Okay, so two continental crusts again coming together. Neither subducts due to the buoyancy of crust. and then mountains form here. This, what they're showing here, okay, is a level of subduction, but if you're looking at the actual continental crust, they're running into each other. This is more so a lower part of the crust that they're not talking about. So they're talking about two of the upper parts of the crust running together to create those mountain ranges. So make sure you guys have that written back on the back side of the convergent boundaries. So an example here is India. India collided with Asia about 40 million years ago, which gave you the formation of Mount Everest. Now, Mount Everest is, about roughly 29,000 feet tall. Is it getting taller every day?
Yeah.
Yes. Okay, you have two converging plates that are still pushing on each other every single day. Okay, so Mount Everest is getting taller every day. Now, yes, it's on a minute amount, right? It's a very small amount, but in comparison to other things, but it's still growing every single day. You still have those two plates pushing on each other, making that Mount Everest taller. So this is a picture of it here. Again, you can kind of see what it looked like before, what it looked like after. So here's your Indian plate, here's your Eurasian plate pushing together. So you have those two crusts pushing together, forcing all of this material to come upwards. Okay? And that's what built Mount Everest about 40 million years ago. All right, next we have this transform boundary. So you should be on the next flap in your foldable. Okay, so you should be on the back side of the next one. Alright, so if you open up, you should be on the back side here of transform. Okay, back side. Crust here is being neither created nor destroyed. Okay, in this process, nothing is subducting underneath, nothing is pushing up. Okay, they are simply sliding past one another. Right? Simply sliding past one another. Okay? Plates slide past, so it's not created nor destroyed, just rubbing against each other. Now remember, what happens to things that rub against each other? What's created? Friction. Okay? So friction is created, alright? And then what can be caused by friction? Buildup. Earthquakes, right? Because that friction buildup causes those faults, which are cracks in the Earth's crust, and then earthquakes happen out of this. Okay, so a lot of times at transform boundaries, you have earthquakes. Okay, so make sure you have these 2 points written down on the back of your transform boundary folder. Okay, so the tectonic plates pass by each other. Here's a great example. You have the one in California, the San Andreas Fault. Okay, so you have the Pacific plate and the North American plate that are rubbing against each other in California, basically. That's the reason why California gets so many earthquakes, because the Pacific plate is moving northwestern and is literally grinding against the North American plate. Right? All that friction buildup causes cracks in the Earth's crust, which then causes earthquakes. Okay, so they connect other plate boundaries together. And like I said, here's the big example, the San Andreas Fault, which is right here, runs right along the coast of California, down into Mexico. So that is why they experience a lot of massive earthquakes down there. Alright, does anybody have any questions? Good. Alright, now listen, you have about 9 minutes left in class. For those of you guys who did not finish coloring, now would be a great time to grab colored pencils. If you didn't finish cutting, grab colored pencils, grab scissors. Please use this time now to finish coloring or cutting. Colored pencils and scissors are on the back table back there. Oh, yeah. Yes. Yes.
Can you put on the board what color?
Yeah, I can put it. I'll put up the directions on the board for you guys.
Yeah.
I got